Alright, ladies and gentlemen, another Monday. Yesterday was Sunday. An awesome race at Talladega. I just want to mention that before we go forward. That was pretty good. I was almost giving up on the NASCAR series, that stuff's boring, but I guess not. They just managed to pull it off. Anyway, what we will be looking at today is the engine that I'm trying to make. Well, I'm trying to fine tune it rather than make it. For the 283 1961 Corvette. That's just because 283 1961 Corvette engine on GM Heritage Center had the ratings posted in gross horsepower and net horsepower right next to each other, so you could approximate how much was lost due to the accessories and all that stuff, and kinda that was very useful. So I decided to take that engine from that specific year and car model for like the smallest engine in the series of releases that I'm going to have. Now I will show you a few websites that are useful in terms of information and where I'm gonna get my references to show you, like, oh, it says this right there and that's why I did this like that. But the end goal is to put these engines into the Camaros and let them loose in a little offline series and see how they behave, tune up the AI and make this whole little setup. I guess before we go into the numbers again, I have to mention a few other things, and for those of you that are actually editing physics or doing it on your own, this might be pretty useful. Let me just find an engine, and this is all from GM Heritage Center. Amazing freaking websites with tons of models and tons of information on each one of them. This is just one of the spots where I'm going to be referencing to, but this is GM material, so the accuracy, I guess, is as accurate as it gets, trusting that they're not lying to you about the horsepower ratings and all that. Anyway, let's scroll down, and find an engine section. It's somewhere here, kind of confusing to see, but here it is. And we're looking at net horsepower versus gross horsepower, and here we have the 5 available engines. Let me take a screen of that rather and post it in Paint so I could draw over it for you. Basically, engine number 1, and that's the one that we're making right now. It's hard to see, but it's just a 4-barrel carburetor, just one guy, 230 horsepower gross, 195 horsepower net. And then again, you could see the numbers for yourself. These are the RPM, and you could see where it drops and by how much. We're gonna calculate these numbers real quick once again. Then the second engine is a dual 4-barrel carburetor, so we have 2 carburetors here, and as you could see, we still have net and gross horsepower ratings. Now that is beautiful. Usually they would have like a net rating for the lower performance engine, but not for the higher performance engine. But there you go. Booyah! This is rare numbers to find right here, the net power numbers for this engine. Then the next one in line, the bigger guy, is a special camshaft. Oops. Blah 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 blah. And once again, you could see right here that it was rated in gross and net horsepower. So this is beautiful for our testing and fine-tuning in the future. GMHeritageCenter.com. Remember this, guys. This is a very useful website. Then the 2 fuel injection versions, which were like probably the best ones at the time, the most powerful, that is for sure, at 315 gross, 275 gross. The 315 has a special camshaft right here that allows it to spin at about 62,000 RPM, at 6200, excuse me. Anyway, but these engines, you see, they don't have net ratings for them. For some reason, Chevy didn't choose to measure them that way. But at least the first 3 in line, we could kind of see and estimate our percentages, how much percent of power gets lost to the accessories and the belts and all the stuff that makes up the net horsepower, for those of you that know what I'm talking about. And here we have 195 215 and 230 in net versus 230, 245 and 270 in gross. Big difference. We're gonna run the numbers, calculate the percentage differences, and just run these three for now, the carbureted versions. Then we'll mess around with the fuel injection numbers, because I have some websites referring to this engine right here, have provided very good information and acceleration times for this engine to take as a reference. So here we go forward, and let's do some quick calculations. And here we go. We got our percentage difference calculator, not percentage increase and decrease calculator, not that one. Percentage difference calculator with this formula. You can look up the website right there at Calculator Soup. Now we're gonna compare and see what kind of drop that we get with gross and net horsepower difference. So 230 to 195 will come around to about 16% difference. Let me write that down with my crooked hand. For the first engine number, come on, engine number A, I could probably type that, huh? 16.47% difference in horsepower. Now RPM wise, I think this one says 48 and now it says 46, so I think it's about 200 RPM drop from gross to net as well. Let me move it right here so you could clearly see. There you go. That's horsepower. Now let's calculate the torque difference. 300 and 270. So original value 300 gross, 270 net. The difference in there adds up being about 10.52%. 10.52% difference in torque. And the drop in RPM is about, I think this says right here 26. I'm not exactly sure, but I think that's what it is. I think this is a 3000 RPM and this one says 26, not 28. So we're just gonna go with that, but it might be 28. So keep that in mind. We have a little window plus minus. And again, this is only one engine from one website on what, like, do not follow these exact numbers for some other engine. I'm just trying to show you the basic principles. You'll understand more the farther we go. So anyway, enough talk, and let's input 400 RPM drop on the torque values. Here we have our first engine difference. Let's go with the RPO 469 option, the next one, with dual 4-barrel carburetors. God damn it. And a special, not a special, a regular standard camshaft. And here we have 245 and 215. 245 and 215, which comes up to 13% difference, roughly 1304. Let's just keep it to the same, and about same 200 RPM difference. You see, from 5000 to 48, and we get here 200 RPM drop. There you go. Let's do the torque now. Same thing. Right here, as you can see, from 38 it dropped to 34. So it's a 400 RPM drop, which justifies our assumption right here about this 400 RPM drop, because we're still dealing with 300 pounds on torque on each one and 270 in net. So we're gonna get the same percentage difference. 300 here, 270 here. It's gonna come down to what, 10%, 10.52. That's good. And then the same 400 RPM drop. Makes sense? On this one, on the second one. The difference is that this one's spinning much higher. This one spins to 38 and this one only spins to 3000. This one is at 34 versus 26. So even though the percentage differences in the torque that we are making is about the same for the single 4-barrel and a double 4-barrel, the RPM that the engine is able to come up with the double 4-barrel are much higher. That's the first difference that you can notice right here. Let's quickly do the special camshaft one and calculate that. It's 270 and 230. So 270 gross, but in reality when you put alternator and starting all the water pump and everything on it, it was only making 230. That comes up to a difference of 16% exactly. And the RPM drop of no RPM drop. You see right there, 6,000 and 6,000. 0 RPM drop. Special camshaft. There you go. The engine at the top horsepower didn't care how much alternator or anything you put on. It could still rev up to 6,000, but it would only produce 230 horsepower instead of 270. An interesting range, interesting output. Again, trusting the GM's not lying about these and blah 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 blah, because they used to, you know, tweak those numbers back and forth. It's a huge mess when you try to research the old muscle car numbers. You're gonna see. Anyway, 285 and 255, and we're about to be done with it. 285, 255. The drop of 11.1%. And an RPM drop of 400 right there, from 42 to 38. Now let's analyze whatever drops that we got. On the horsepower, we have about 16%, 13%, 16%. On the torque, we fall off about 10%, 10%, 11%. And then on the RPM, the horsepower usually drops from 200 RPM to about no RPM drop, so that's your range from 0 to 2. And then torque gave us very good, very stable readings of 400 RPM drop each time from gross to net. Now this is your first kind of key clue numbers, which you're not gonna see anywhere else. That's what I wanted to show it to the people that are actually editing physics. This is the windows that I'll be working with. You should calculate your own as long as you can find the gross and net horsepower ratings of the same engine. If you already have net horsepower ratings, just net, forget about the gross horsepower. Don't even worry about them. Just run your net numbers and you're good. But if you're doing like an old school or a muscle car where the ratings are in gross horsepower and you have no net ratings and you're trying to figure out what the net ratings should be, for example, like in our engine right here on the fuel injection, we have no net ratings for that one. So we're gonna approximate how much everything dropped right here and apply this theory and this basic concept numbers to this engine and kind of try to approximate the net numbers for the last two engines in our lineup. And this will summarize the top 5 engines that are going to be released soon enough. Let's go to the next segment if we still have any time, and I'll show you the next thing for today. Time flies fast, so we're almost out of it for today. Let's see how fast we can calculate our BMEP values from the theory before. Make a tic-tac-toe grid, put the RPM here. We're gonna do the net ones at 46. We're gonna do this one at 26. We're gonna see how much horsepower are we making here. 195. How much torque are we making here? 270. That's all net. This is pounds of torque, and this is horsepower. Done deal. Pull out our hefty calculator. Now let's go with the formula. 195 horsepower times 52 divided by the RPM makes us 222 pounds of torque here. We could calculate horsepower for this one, but it's not needed, but we'll do it anyway. 230 times the RPM divided by 52 comes up to about 133 foot-pounds of torque here. So this is our, well, I mean horsepower. There you go, we got our numbers. Now let's do the BMEPs. The BMEP for this one would be very easy. 222 times 150.8 divided by 283 comes up to 118.29. do that in red. 118 basically. Let's just go with that. And then this one, same procedure, 270 times 150.8 divided by 283. This one be 143.87. Just like from the previous video. We're gonna run these numbers and see where we land.